We are going to finger cross that it is not going to freeze for us. Or cross our fingers. English is hard for me sometimes. Good at math, bad at English. All right, so what we're doing today, guys, is kind of reintroducing factoring and solving by factoring. It was funny because I asked, my last period class, you guys did this in Algebra 1, do you remember? And of course everybody says no. But I think that it will start to come back to you the further we get into today's lesson. But you did do it in Algebra 1, but I know, guys, it's been 2 years. So I'm going to teach it to you like it's the first time you've seen it. But it may come back to you as we're going through. Okay, so to solve quadratic functions in standard form looks like that. If you look at example 1, it's exactly what standard form looks like. Should be really, really similar to what you guys saw with graphing too. Actually, not really similar. It's exactly what you guys saw with graphing. So we're going to solve them in 3 different ways. Today, we're focusing on trinomials. Do you guys know what a trinomial is? Thank you, Pedro. Trinomials. You have 3 terms. Yes, tri means 3, so it means you have 3 terms. GCFs and the special factors, difference of squares, we're going to learn both of those on Friday when I am here again. And then Monday, we're going to kind of bring it all together and do all 4 of them. Biggest mistake or biggest problem that we've had with factoring and solving is not knowing which of these 3 to use. So that's why we're bringing it all together Monday so that we can practice figuring out which one we're going to use first, then actually going through the process of doing it. All right, so the goal is to solve a quadratic function. You learned, especially with that quiz you guys just took yesterday, you learned how to solve a quadratic by graphing. And remember, when we were solving by graphing, where were you looking? Where on the graph? The x-axis. Yes, absolutely. So where it crossed the x-axis, that was your solutions. You're going to learn how to solve it with algebra in the next few days, of lessons. At the very, very bottom here, it says you will usually end up with 2 answers. So the 2 answers was because it crossed the x-axis twice, right? But you also learned there were 2 other possibilities. What were the 2 other possibilities? 1 solution and no solution. So 1 solution was because why? It was sitting, right? Sitting right on the x-axis. If you had no solution, what did that look like? I didn't touch the x-axis at all, right? It went in the opposite direction of the x-axis. With factoring, you guys are not going to see no solution. The no solution doesn't come until you guys start learning how to do the quadratic formula, quadratic equation, things like that. You could potentially see 1 solution. But for today's lesson, you're only going to see the 2 solutions. Okay? So we're going to solve both where a equals 1 and then also where a is something other than 1. So there are slight differences, but for the most part, they are exactly the same. All right, so let's get started. Very first thing you have to do, according to this box right here, you have to set your function equal to 0. Guys, we had to do that with graphing too, right? So that's not any different from what you've been doing for the last few days. So set your function equal to 0. Then you'll factor using one of the 3 techniques, but today we're only going to focus on trinomials. And then after you factor it, you're going to set both of your factors equal to 0 and solve. And then those are your solutions. Okay, so let's get started. First thing you're going to do after you set it equal to 0, because this one is already equal, so we're done there. We're going to do a concept called an ACB chart. So So the ACB chart, the A, the C, and the B, obviously they all come from your equation, right? When you look at that example 1 equation, what's your A? What's your B? -2. What's your C? Perfect. So we're going to do A times C. That's that AC column. A times C, you guys just told me, is 1 and -8. What is that? Just -8. There you go. So that goes in that column. And then the fact that that is negative gives us two very important things. Okay, so that negative sign, and if it's positive, it gives you two very important things, but they're going to be slightly different. So the first important thing that that gives you is that you're going to be subtracting the numbers in whatever we find to be in the B column. Okay, so you're subtracting your B column numbers. The second very important thing that it gives you is that your signs, when you go to put it in your parentheses, your signs are going to be opposite. Make sure you write down those two things, okay? Okay, so the B column is what multiplies to give you the number that we just found in the previous column. Always start with 1 in itself. Most of the time it's not going to be 1 in itself, but sometimes it is. And in fact, you're going to see one today where it actually does work. So always start with 1 in itself. And then what I always do, and this is very helpful to you guys because most people are like, I don't know how to find all my factors. Just go up numerically until you found all of them. Okay, so we found 1 in itself, so go to 2. Does 2 go into 8? Of course it does. So 2 and 4. And then guys, 8 is a really small number, so you probably realize that you can stop there. But you're going to see a problem later where there's like 5 or 6 different sets of factors. So in that case, and you'll see when we get there, but in that case, you would just keep going. Okay, does 3 go into 8? No. Does 4 go into 8? Yes, but we already have 4. Okay, so that's how we know we're done. Okay? Are you okay so far? Any questions so far? Okay, so now that we have everything listed in our B column, we're going to go ahead and set up our shell. I kind of call it a shell because it's just the parentheses. Set up our shell. You're going to start by separating the x squared into x and x. Now, see down here where it says signs are opposite? So that means you're going to go plus minus. Okay? And then see step 1 where it says we are subtracting the two numbers. So when you subtract the two numbers, what you're wanting to get is that middle value, that B value of -2. So can I subtract 1 and 8 to get a -2? Obviously not, right? But see how we can subtract 2 and 4 and get that -2? So then your next question, because your signs are opposite, and it matters the order that you put it in because we want that -2. Okay, so am I going to go 4 minus 2 to get a -2, or am I going to go 2 minus 4? 2 minus 4. So 2, 4, and that goes in there like that. Okay, positive 2 minus 4 gives you that -2 in the middle. Yes, sir?
How does the greater value supposed to be positive?
Well, to get a -2, your greater value has to be negative. Do you see what I mean?
Yeah.
It's because your B value is negative. If it was positive, then yes, we would go 4 minus 2 instead. All right, last step is taking both of your factors and setting them equal to 0. So, can you guys solve those in your head? Probably. X plus 2 equals 0. X equals what? -2. X equals what on the second one? 4. So just bring it down here. We're just going to write our answers side by side like that. And there we go. Your answer order doesn't matter. So if you had that as 4, -2, you would still be correct. Okay, so far. All right, next one. What do you notice about this problem? What do we have to do first? Say it again. Got to make it equal to 0. Perfect. X squared plus 9x plus 14 equals 0. Next step. ACB chart. Perfect. Okay, when you go to do the rest of the problem, make sure that you are looking at that equation, the one equal to 0, not the one that was originally given to you. Multiply A times C, what do you get? Perfect. Now, see how the 14, that AC is positive this time? I'm going to put a positive. You don't have to do that every single time, but I want to do it just to show you the two very important things on this one. So on the last problem, we said that the negative meant we were subtracting. What do you think the positive means? We're adding. Okay? On the last problem, the subtraction sign meant that we were using opposite signs in the parentheses. What do you think a positive means? Same sign. Okay, now the same sign, it's either going to be plus plus or minus minus. When we go to plug these back in the parentheses, I'll show you how to tell the difference. All right, what goes in the B column? 1 and 14. Whoops. 2 and 7. And then again, you would keep going, right? But that's it. Yeah, that's all we have for 14. The lower numbers are super, super easy. All right, so let's go ahead and put these in parentheses. Separate your X's. Okay, so I told you I would kind of show you what to look for. We know that the signs are the same, but we have to figure out if they're plus plus or minus minus. So what you do, remember on the last problem, that B value is really important in helping us figure out what numbers go in there. It's the B value again. So see how that's a plus 9 for your B value? That tells us that it's plus plus. So it's your B value that determines your signs. All right. Which one, we know we're adding, which one adds to give you 9? 2 and 7. I do want to point out, the signs are the same, so does it matter which one I put where? No. Could I have put 7 first and then 2? Absolutely, yeah, it's the same thing. Okay, we are done with factoring. Now what we have to do is solve. X equals, if we set this first one equal to 0, what's that? Minus 2. If we set the second one equal to 0, what is that? Negative 7. And that's our answer. All right, example 3, what do we do first? Set it equal to 0. X squared minus x minus 30 equals 0. And then I'm going to cross that off. Next step is your ACB chart. Multiply A times C. What do you get? Negative 30. Negative tells us two very important things. What does it tell us? Opposite signs, and we're subtracting our numbers. Perfect. All right, what did I tell you to always start with? 1 in itself. Perfect. And then keep going up in numeric order. Does 2 go into 30? What does it give you? Perfect. Does 3 go into 30? Good. That gives you 10. Does 4 go into 30? No. The next one would be 5 and 6, right? Now, I will tell you, when you get a problem where there's multiple factors like this, see how 5 and 6 are really close together? They're right next to each other, right? Typically, when you get two numbers that are really, really close together like that, that usually tells you that you're done, okay? That there's not going to be anything else, any other factors that you need to do. All right. Let's set this up. X, X. You guys already told me. What do we know about the signs? They're opposite. So plus, minus. You also told me that you are subtracting. So which one of those subtracts to give you that -1? Austin, you said it. 5 and 6. So this is what we're using. Remember, you're looking at B to tell you what goes where. Okay? We need a -1. So are we going to do 6 minus 5 or 5 minus 6? 5 minus 6. So 5 goes first. Then your 6. Perfect. So X equals, what is that solution? -5. What is this solution? +6. Perfect. Questions? You guys good? Do you remember doing this in Algebra 1? Yeah? Is it at least coming back to you a little bit? All right, I'm going to change this to 4, 5, and 6. All right, example 4. What is the difference in these three problems? X does not equal, or A does not equal 1, right? So that beginning number is something other than 1, but we still go through the same process. That C looks really weird. Still go through the same process. It's just you have to recognize that there is a number in front of X squared. So 2 times 3 is your A times C. That gives you a 6. Still positive, which means what two things? Addition, same signs. Perfect. All right, let's go through. 6 is super easy. 1 and 6, 2 and 3. Finally froze. So sad. I thought we had it. All right, where were we? We were doing the ACB chart, right? B, we had a 6, we had 1 and 6. I was trying to do the 2 and 3. There we go. Okay, so you already told me same signs, and we're adding the 2. Which one of those two adds to give us that middle value? The 1 and 6. Perfect. So let's set up the parentheses. Now, the main difference when you have a value in front of X squared, the difference between this one and the one up above is we actually have to take that value We have to make sure that we take that value when we separate our x's. Now, obviously, if I multiply 2x and 2x, it's not going to give me 2x squared. So one of those is going to reduce like a fraction when we get to the very end. Okay? All right, so you guys said 1 and 6. You also said it has to be the same sign. What is the sign that it needs to be? Positive. Where did you find that? In the middle. Yep, your b value is positive. So your signs have to be plus plus. Now, remember I said at this point, you're going to reduce one or both of those like you would reduce a fraction. Which one of those looks to be able to be reduced? The 2x plus 6. This one right here. So what I mean by it can reduce like a fraction is like that. If I had a fraction that was 2 over 6, you would reduce that to what?
1/3.
Did you keep the 2 somewhere? No. We just reduced it naturally, okay? And the reason that I said that you didn't keep the 2 is because when we get into GCF, you're going to want to think that it's the same type of concept, but it's not. What can we take out of both of those terms? A 2, correct? So Rewriting, we've got 2x plus 1, and then dividing this by 2, we have x plus 3 equals 0. This one you can do very easily, right? What is the answer to this? X equals -3. So at this point, you guys have figured out to solve a set of parentheses, when it looks like that, you just change the sign. But what about something like this? 2x plus 1. There is also a shortcut with this, but I'm going to show you the long way first. Solve for x, what do you do first? Subtract the 1. So you have 2x equals -1. Now what? Divide by 2, so that gives you -1/2. There is a shortcut that you can do. So we changed the sign on this. That one was really easy. The shortcut on this is we're still going to change the sign, and then you can always go last number divided by first number. See how that still gave you that 1/2? So you can do that if you want to, but if that's confusing and you don't want to do it that way, you can always just solve it like we did. All right, final answer. X equals -3 and -1/2. All right, let's try another one. It's already equal to 0, so we can go right into the ACB chart. A times C, what is it? 72. This one's going to have several options. Always start with 1 in itself. Then keep going up. Does 2 go into 72? Yep, leaves you with 36. Does 3 go into 72? Obviously, because that's what we multiplied to get it. Does 4 go into 72? Should. 4 and 18. Does 5 go into 72? Does 6 go into 72? Does 7 go into 72? I think 6 and 12. Or does 8? No, 8 does, right? What is it? 8 and 9. There you go. And those two are really close together. Remember, I said when you get to two that are really close together, you are typically done. Okay. Remember, guys, when you set up your parentheses, you have to take that A value with both. Then we will reduce later. Okay, it's a positive 72, which tells you what two things? Same sign, and you're adding. Yep. So what is that same sign? Negative. How'd you find it? It's your B value. Perfect. So it's negative, negative. Which one of those factors, 8 and 9, gives you the 17 when you add? All right, signs are the same, so does it matter the order? Nope. Which one of those can be reduced? There you go. Divide that by 3. So we have 3x minus 8x minus 3 equals 0. So shortcut with this one, we're going to change the sign, so it's going to be positive, and then go last over first. So that's going to be 8 over 3. And then what's your second answer? Positive 3. And there we go. Last one, guys. ACB chart, I'll just tell you it's negative 30. Siri talking to me? Is that Siri? All right, 2 and 15, 3 and 10, 5 and 6. We've already done the 30, so. All right, separate. Set it equal to 0. Bring that 2 with it. What are your signs? Plus and minus. Because that AC was negative, that also means we are subtracting. Which one of those two subtracts to give you 7? The 3 and the 10. Okay, it's a positive 7, so is it 10 minus 3 or 3 minus 10? 10 minus 3. Which one of those can be reduced? The first one. Divide that by 2, so that gives you x plus 5. 2x minus 3. Okay. Set them both equal to 0. X equals, what is the first one? Negative 5. Do you guys remember the shortcut for the second one? Change the sign. Last over first. So 3 over 2. Perfect. All right, guys, on the back is